Yes, okay, hello, hello, hello. I'm usually quite mobile on the stage, but with the demos and with the microphone situation, I will be the camera person's best friend today. Yeah, here's an email that I may have received from Sarah. Hi, this is gonna be hard to do. Oh, I can do this. I pushed commits yesterday, but they're not showing up on my invoice. Last week, everything synced fine. Now, some commits appear within minutes. Others never show up at all. I need to send this invoice today without any kind of greetings or anything, Sarah. And you can see I come from the Pacific Northwest of the US, and I've been living in Austria for a while, and there's like a intense passive-aggressive sort of feeling in both of those places. And I can read that in this bolded area, that she's very, very upset with me. Yeah, so I am Aaron. I've been doing Elixir for a while. I did Ruby for maybe a decade. And yeah, I have been working now lately. The machines have made it easier for me to actually finish side projects. And lately I've been working on this side project called Bill My Commits. We can look at it real quick. Is this gonna work the way that I want it to? Yeah. So anyway, I can't actually see it from here, so we can try this. So it's a freelancing tool where you can bill your clients essentially from your GitHub commits. You sync your repos and your commits, and then you can create invoices from them. You can create an invoice here. It loads my commits, and I can pick a couple and create an invoice. And then we get an invoice that we can preview or save. And yeah, you get a PDF copy. You can send an email to your clients. Thank you. Yeah, so we have also a little demo. If I can find my mouse guy here. I made a demo app, a Rails app for this talk. It works with all of the infrastructure that I have in Docker containers on my laptop. And you can do kind of a similar thing with sync the repos, et cetera. Yes. So this email comes in the morning, and by the end of the day, I had found some sort of a fix for it. And we're going to go through kind of, this talk is going through that process, how it was, and kind of how it could have been. And to start, yeah, so I was like, hey, Sarah, can you give me a screenshot of your commits? She gave me one. You can see that she had 14 commits on her repo, but there were only 12 commits in our app. So we immediately know something is wrong, but we have no idea what it is. So the first thing that we do is we go to the production logs, look through them for errors. This looks pretty good. I don't see anything weird at all here. So guess I'll try and actually grep for some errors. And then what's so fun is we have 0 errors, or maybe I can. And yeah, so that's super helpful, 0 errors. So maybe our jobs are breaking. We go to our jobs dashboard, and the jobs are also, I don't know, around 0%. A failure rate, so that also looks good. The system is telling us that everything is good, but we know that everything is broken. We've seen it with our own eyes. The user is telling us. And we need to kind of look at the things that we know, the things that we don't know, to try and come to some sort of a solution. So something's obviously wrong, and the things that we don't know are what is broken, who is affected by it, and like, has this been going on for a month? Like, invoices are generally created probably every month, so maybe it's been going on for a long time, something that we need to figure out. So I think that most of us have been in this situation where there's some kind of an error that we can't see, or something that, like, an exception gets raised and we're like, where is that coming from? Who is it affecting? And the problem that I have had is that I was only concerned about kind of what errors might exist, but I wasn't actually concerned about if the users were getting the information that they needed when they were looking for that information. So let's fix that in the next few minutes. But first of all, a little bit of audience participation. Does anyone have an idea of what it might be? I've been living in Austria, and we have these like little wafer things that I like to give out for talks that are called Manoschnitte. Did I say it good? And for people that have an idea of what it is, I don't care if you're wrong or right, you get a Manoschnitte. I don't have a lot of time to do this, though. Does anyone hands for an idea of what went wrong? I'm not going to tell you if you're right. Does no one want a Manoschnitte? We got one over here. What? It's a good guess. Time zones suck. I'm sorry, this guy first? Force push? That's another interesting guess, maybe. In the back, there was this one. Caching? That also sounds like quite a good possibility of what it might be. And we got one last. We have so many hands now. I don't know you can get these two? There's mini wafers in each package, so you can share them between other people that have raised their hands. Just yell it out over here, and the loudest person. Validation. What? Database validation. Okay, I like these. I like these ones. Cool. So all of the Manoschnitte, and find your nearest Manoschnitte person if you want one. They're vegan. Yeah. So this talk is kind of exploding one small part of Andre's talk. I was kind of freaked out when I read his talk title. I was like, is this going to be the same talk as my talk? And then luckily it wasn't. And the first thing that we're going to look at is metrics. Generally observability, yeah, like Andre said, you have metrics, you have traces, and you have logging. Metrics are numbers over time, essentially, like aggregated numbers over time that you display in certain ways and can figure out things about your system from them. The piece of software that we will be using for our metrics collection is something called Prometheus. Generally, it kind of does things a little bit differently than traditional metrics systems. Instead of pushing, like every time an event in your system happens, you push it to Datadog or to New Relic or somewhere. That's kind of the normal way that we think about events and metrics. Instead, you expose an endpoint on your application or somewhere in your system that has data on it, and then Prometheus will scrape that data every n seconds. So I think default is about 15 seconds. It's a time series database, so it stores that information, those numbers that you give it, alongside a timestamp. And then later you can do things to aggregate those in the future. So you have this metrics endpoint. It kind of looks like this to people on the right and the left. You can see on yours. And you have a configuration file where you tell it kind of the IP address or maybe the domain of the thing you want to scrape. It goes well inside of Kubernetes clusters. On one project, we're doing this. It monitors itself. The other Prometheuses can monitor themselves, kind of like a whole. And yeah, or also I have in some projects a VM that just has Prometheus in a private network. So just to show you kind of what this looks like, another blind situation here. This is our metrics endpoint, and it looks very small. I made it smaller instead of bigger. I accidentally bought a computer with a German keyboard, so it's mapped to US right now, which is fun to look at the keys. And you can see that there are these keys. There's kind of these documentation. That helps also the consumer be able to tell you what this metric is about. And you have the metrics themselves, labels that go along with them, and then some sort of a number that is an aggregation, probably. Okay. Wonderful. Yeah, and so you kind of need to think about it a little bit differently, that instead of aggregating after all of the things get created, like taking all of the entries and then aggregating over them. You instead create your aggregations up front, but then you can aggregate over your aggregations later. But you have these totals and things that you're scraping instead of like grouping things together. There are definitely trade-offs with Prometheus, though. You don't have specific information about specific users, for example, or specific requests, because there's this idea of cardinality where each entry that you just saw on that, for each label combination, it needs to add another line to your file or to your metrics endpoint. So if you had like user IDs as one of your labels, then you would have user IDs times the amount of this other label possible times the amount of this other label, which then exponentially grows. And then you have a page that's like 30 megabytes that needs to be scraped every 15 seconds. I've seen this on production before with people that weren't used to Prometheus yet, where the page took like 10 seconds to load or 15 seconds to load, so there were scrapes missing in between, and it's like, ooh. So yeah, you have to look out for those things. You can't find information about specific users and specific requests, which sucks for certain use cases. But you can look at these counts. You can look at kind of gauges like users online right now counts. You have a lot of possibilities. If you do need requests, like the request time, duration is a better word to use, you can throw these things into buckets of certain time amounts and then do a histogram, which is just creating kind of a value for each of these numbers. And then you can find percentiles of that and then use that in your dashboards and in your alerts and those types of things. Yeah, and counters can only go up. Gauges can go up and down. And histograms are like counters, but with these buckets. And those also make it so you can use different query functions on them. But I'm not going to go too into detail on that. Yeah, so it's nice. Like I get by with Prometheus on a pretty large scale application that I work on, and smaller ones as well. But you may need to, if you need to know these certain things about requests, use something just for those types of information, like a Datadog or New Relic. Yeah. So to add Prometheus to your Rails application, there's a few gems. The exporter here is a server that runs that exposes this metrics endpoint. And then the two other gems are what you use to kind of generate this page that we just looked at, like what you use to log information that shows up on that metrics page. And then you can create different metrics with a block. The group gives you some more of that. The underscore is the metric name, and then the exact metric name at the end of the underscores, and this cache hits or cache misses, and then you can pick a counter, a gauge, a histogram. There's also something, I think it's called a scalar. Does anyone know what the fourth one is? No? I've never used it before. It's like some other kind of histogram. Maybe it's really cool. Probably not. Yeah, so we're going to go into another hard-to-do demo. Was I on the right thing? So here is a dashboard. You can see that it has a lot of data. Uh-oh, reloading. Don't warn me. So we can go to the demo app. Can I do? No, I'm not going to do that. My commits demo. We want to sync all repos. Do it a couple of times. Generate an invoice. I'll just get really loud when I turn my head. Sync all repos. Now we need to wait for Prometheus to scrape our stuff. This is Grafana. Grafana can connect to different data sources like Prometheus or Elasticsearch or Postgres, InfluxDB, and you can create dashboards and panels very simply using queries for each of those types of data sources. Oh, what's happening? I see we have some data. We'll have more data in a second. And yeah, this isn't real time. It pulls every 5 seconds, so you can change the pulling time. We have, ooh, look, more graphs. 0 requests per second. I don't know if that's what we want. Yeah, so we have now, we're seeing that Our cache age is 2 days. That seems a little bit maybe not like something that we want. Maybe it's completely normal. But now we have kind of this idea of what might be going on in the system. Cool. Yeah, so it's been 2 days since the cache updated. This is definitely like a red flag. So we're never fetching this new data, and we need to find out kind of why this is happening now. We know what is happening, that we have this cache old situation, but we need to figure out why. And that's where traces come in. And traces are, you can kind of follow a code path through your whole system. You can add meta information to different parts, to function calls, to external API requests. And there's certain tooling that you can use to connect to that. We're using OpenTelemetry. It's a standard that lots of different services and different open source kind of these monitoring tools knows how to communicate with. This system generally works with, you have an OpenTelemetry collector, so you're actually pushing data to this collector, and then on the other side you have a metric system, like a dashboard system like Grafana or Datadog, that is then consuming from this, this OpenTelemetry collector, and then you can create your graphs and your alerts from that. And to add this to a Rails project, you grab this OpenTelemetry stuff, you need to configure it, you give it an application name, and then you have, with this gem comes some Rails-specific things that you can lock into, but you can also then set up your own traces. Here we are creating a trace around our fetch commits. We're setting some attributes, so we're adding some metadata that we would be able to see throughout this whole process, this whole kind of run down the line. And yeah, we did that in our demo app. There's a little issue with the demo app that the attributes didn't work really the way that I planned, but we can look at kind of a fake version of it. And where are you? Okay, guess I got to open you. This is fun. Yeah, and one more thing I have to do is I do it here, actually. You don't get to see. I get to turn on the traces. The app is running new. And so let's do this thing again. We want to sync the repos. Push it, just spam it. It's about 10 times. And then it's fun to watch me move the mouse around. So here we have the service that we want to connect to. Maybe I can stand here. Does that work? The service we want to connect to. The problem here is that their UI is a little bit broken on my computer. I don't know what the reason for that is. We have this operation that we're following, and then we can look at the traces. And here are 20 traces of what's happened. We can look in the process, and we can see for each thing that's going on. Here is the interesting one for us, this fetch commits. We can dig into that, and then there's a hidden thing here where we can see that the cache age hours is 51.55 hours. We don't like that. What we're missing here, though, is the user ID and a couple of other things. But those should be added if you are doing this better than I am doing for my demo. And yeah, you can dig down deeper into, you can see how long things take. You can add different deeper down, like after the request. In other systems, you can connect to it if you pass the trace ID onto them. So it's a pretty powerful tool. This tool here is called Jaeger. It's open source. It's written in Go. You can run it on your servers or locally. You can also use Honeycomb, not Honey Badger, right? Which has a very generous free plan as well. So if you want to test it out, wonderful. And yeah. Yeah, so what we expected to happen in the demo was that we saw that some of these are hitting the server, and some of them aren't. And that the cache is 47 hours old. It's hitting the cache. But the important part here is we see that GitHub is actually returning a 304 for all of our requests. Our E tag seems to be not changing. So it's GitHub's like, dude, you have the updated data. We're not going to give you anything more. And my system's like, OK, we trust you. It's been 2 days. Maybe that's reasonable in some cases. For us, it isn't. So we have now an idea of what's actually going on. And now the next step is kind of like, we know what's happening. Who is this happening to? And we can get there by using structured logs. And structured logs are just, instead of just plain text, you are taking your logs, you're adding metadata to them, and then outputting them in some sort of a file format that can be consumed easily by an external service, JSON in most cases. And then you have some kind of a log server that's running that you're pushing your logs to, or it's reading logs from you. And then you have the possibility of aggregating them and actually seeing important information inside of your logs. So here is an example of a log that we might give with our user information, catch hitting. This is like after the fact. We're like, oh, bad things have happened. Here are some things we might want to know about in the future. In this demo, I will be using Loki. Loki is a service that is made by the people that made Prometheus and Grafana that allows you to tail your logs and then have it consumed in their time series database. Or, yeah, there's other ways to push it to it. And it can live inside of Grafana. So if you're already using Grafana, it might be a nice use case for you. There's less kind of moving parts or infrastructure that you have to deal with. You can also deploy it to your own servers. So if you have a smaller project or if you like to do everything in-house, it's a great solution. And I need to change to the right thing here. OK. So we're going to hit this again. Sync, 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 sync. And now we have Loki open, I think. Are you good to go? Yes. So you can pick. This is not fun. You can pick the different event that you want to kind of filter on if you want. In this case, we're doing event cache, GitHub cache hit. You can see kind of a history of when these things have happened. You can look deep. I don't want to open my downloads folder, but I think I did. You can look deep into your logs, and you can aggregate on different kind of information and find out counts for different combinations of logs or look for specific logging. And it's all here just like saved on my VM that I'm running or in a Kubernetes pod. Yeah. Yeah, and in our case, in the not demo world, we aggregated and found out that there were actually 126 users that had a cache timeout of longer than 24 hours. Which sucks. I guess it could be worse, but 126 users, now we know. And yeah, so we need, like, this is kind of a terrible solution, just heads up. The decision just to go forward to make things work again was to check the cache age before, and if it was above some sort of a threshold, to then say, actually, the cache is old. You need to re-request the things. So quick fix, yeah. New, 24 hours is a random time. Your mileage may vary. And so now in the world of having metrics, instead of it taking all day, it took exactly 93 minutes, exactly. And yeah, we were able to get to the solution much, much quicker. So that's all fantastic, but I think we can get a little bit better. And there's a whole other world of alerting. You can do this alerting through Grafana. It just runs in the background. You give it certain queries to run and tell it thresholds to give you alerts about. So here are some kind of traditional alerting situations you might have. You can kind of aggregate these values, and then if they are above a certain threshold for a certain amount of time, then you can create an alert. An alert is a message sent somewhere. Grafana is great, and it connects to Slack, it connects to Telegram, email, I think maybe SMS. It connects to a lot of the things, and it's pretty easy to set up as well. So you can have can have a pending state where maybe this error state, if it's only going on for 5 minutes, then that's okay. But if it goes on for 6 minutes, then I should know about it. And all of that stuff is pretty easy, like programmably. So you can just store that infrastructure as like in your code, or you can also set it up in the dashboard pretty easily as well. And so we move into this world of, instead of being reactive to getting emails or phone calls or alerts from like nothing working at all, we get into this world of like having very specific alerts that we can react to and fix the things minutes after they're broken, instead of like getting that awful email in the morning. And some examples of some different types of alerts for us. This is what a Prometheus query looks like a lot of the time. You can say, if this rate is greater than 0.99 for 1 hour, then the alert should happen. So you can average things, you can find a maximum, you can find an increase. So if the average cache age hours is greater than 6, then we want to alert, even though averages are also very questionable at times. And if you're having any amount of API calls, like if you're getting 0 API calls in the last hour, maybe something is weird, so we could add that as an alert. So now we have these alerts going on. We can immediately after the alert look into our metric systems. We can then fix it and deploy a fix in, how many minutes is this? A half hour, close to? In a half hour instead of 93 minutes now. So wonderful. The users probably don't know, and you've saved yourself a world of hurt. I think that I have a little. Is there a? I'm good. I'm gonna keep going. So we have some anti-patterns here too. You want to track kind of what the good thing is that your users should be getting, not just error situations. You can't just trust external services, kind of maybe wrap those connections to external services in some sort of a tracking or a logging or a tracing. Yeah. For us, the cache age mattered. And yeah, you needed to really watch out if you're using any of these systems, also for things like influx, that high cardinality things are bad. If you're using something called tags or labels in most of these observation tools, generally that's something that you don't want there to be thousands of. You want there to be like an enum if you're using, are there enums in Ruby now? Okay. If you're using another language that has enums, so the kind of maybe like 5 things or 3 or 6 or 10. Otherwise, you have this explosion of metrics that is not fun to deal with. Then you also run out of data on your timescale or your time series database, and everything crashes because, yeah, it's not good. So yeah, here are some things that the next day we could work on. And I really highly recommend that you create a plan to add these things, maybe slowly if possible, to your existing systems now, so you won't have these problems in the future. Also, I kind of have this same feeling that I have with automated testing, where if something happens bad on production, that I will then create a failing test, and then that test will then be like, I'll make it green, and then that whole failure thing, I have a test for now. And that's kind of how I feed back this whole feedback system into my observation as well. Something bad happens, we need a metric for that now. And then we track that, we create alerts if we think it's important. And really, this is something I've been trying to think of. I procrastinate a lot, and I've been trying to think more about my future self, like it's kind of, hey guys, kind of an external person that I care about and that I want to treat them better. For like all of the things. And this is also like, as Andre was saying, like, I would never want to be a sysadmin because anytime anything like this happens, my heart rate goes sky high and I do not feel good. And the whole time I'm like, so like, yeah, be good to yourself and take care of this stuff up front if you can. And yeah, so I have this demo app along with the Docker Compose files here at this repo. You can go through, use the bin demo to kind of set it up in different situations. It has Jaeger running and all of the Prometheus exporters and all of the things that you need. All those things are running. Everything that you saw is running locally. So if you want to play around with this stuff to see how it works locally, like, good stuff. There's a nice README for you. Yeah, and if anyone's interested, like, the soft launch will be happening very soon. If anyone's interested in this product at all, like, I would love 1 or 2 people, 3 people to test it. Come to me, and thank you.